let's get going. Thanks for coming. I'm Garrett Smith. We're going to be talking about some weird things here. So if you're in the room and you came to this talk, you're a weird person. So welcome. I appreciate it. Okay, so originally this was entitled, what was it, the Functional DAO of Bash. I changed it. It's something different. It's now entitled Refactoring in Bash Functions and My Personal Neuroses, and I wrote this title just like 10 minutes ago. Because I finished it and I'm like, okay, this is the right title. This is what you're going to hear. But you're probably a little disappointed because you're like, I really wanted Bash to be a functional language. You're going to learn that it's not a functional language. But just to appease you, because I know that you wanted to hear functional language things, I've got 2 points here. Okay. There is a little bit of functional stuff going on in Bash. I'm going to give you 2 things, and then we're going to throw those away and then get into the really bizarre stuff of the talk. All right. So, this is unfortunate. No one can see this. This is not going to work. So we need to turn the lights down enough so we can see the screen. Yeah. How does that look to everybody? Can I turn this up somehow? That's not going to work, is it? Yeah. So you can't see this, but this is a list comprehension. I tweeted this. I'm like, I wish there was a list comprehension in Bash, but there actually is a list comprehension. This is a list comprehension in Bash. So what we're doing here is we're finding a bunch of files with find type dash type F. So it's going to find file. You can run this now if you have a laptop here. It's super fun. Pipe it into xargs. So this is a generator. I'm going to define my variable here as being the line items coming off of each of these. So this is going to generate a bunch of lines. They're going to get passed in as standard into this guy. I'm going to use f as a variable, essentially, as a representation of that. And then it's going to transform that f by pulling off the base name. That's a list comprehension. It's also an example of a higher order function in Bash. What's the higher order function here? Xargs. So Xargs knows how to handle standard in and parse it and then pass it on to a command. Okay? That's functional. It really is. All right, so you should be satisfied at that point, but I have one more. Check out this. I just created a map. This is a map function in Bash. So look at this. This is the code. Map, I'm going to pass in a function to apply, and then I'm going to pass in a list. Right? So here's map. I'm basically going to grab this as a string, because it's Bash, right? And then I'm going to evaluate it, because it's Bash. I can do crazy stuff like that. I can just take a string and evaluate it. Right? And I loop through my list of arguments, and then apply each argument to that function. That's functional. That's it. That's all I'm going to talk about. It really isn't a functional language, but I would consider myself a fan of functional programming. By the way, thank you for coming, Phil. I believe that Bash is a discovered language. I don't believe it's invented. You discover, it's always existed, right? Bash has always existed. And anytime you search for something, you discover more of Bash. It's everywhere. It's something discovered. I think that that's the universal or omniversal language. It's the thing that says, go do stuff. Right? That's like the most fundamental thing of the universe. It does stuff, and Bash is the best at doing stuff. That's did I prove that? Is that sufficiently? Did I prove that? I didn't. That's probably. You don't seem convinced.
For some sufficiently unsound notion of truth. Yeah.
Thank you. Well, I will accept that. Check. Right. Okay. So that's my take on Bash as a functional language. But we're going to get into some functional stuff. So that's still going to come. All right. This is really a real life story. It involves a Bash script, a single Bash script. We're going to take a look at that. It's short, so we're going to be able to get through it. 140 lines, no problem. It's named CI.sh. Now, CI in this case stands for continuous integration. I work at CloudBees. We are the Jenkins shop, so we do our own CI, and that's what CI stands for, continuous integration. If you're not using continuous integration, it's okay. If you discover bugs in production weeks down the road after something has been committed, CI will help you fix that, but it's not strictly necessary. So right off the bat, I'm going into this thing uncomfortable because I don't like the SH extension. I just like it to be a command, so that's kind of bothering me. You can kind of see I've got a little bit of OCD going on here. You'll learn more about that. And then the CI name bothers me, because that basically is like do stuff, run.sh. So that's bothering me. I'll get into this as a backstory. But let me defend Bash for a moment. Who are any DevOps people here? See, this is a word I reject. I also reject the word cloud, because I like to use the word internet. So DevOps, I reject. I use sysadmin, because that's what we used to be called. But the difference between a sysadmin and a DevOps engineers tend to use Ruby, right? You wouldn't, no self-respecting sysadmin would use Ruby, and so Ruby came in this language for back-end scripting. It's like, well, we need a new space for this. We need a new term. So this is old, good old-fashioned Bash. The reason that we're using it in this particular case is we're deploying software. We didn't want to have a bunch of prerequisites. Bash is basically everywhere. It's pretty portable across systems. It's actually quite portable. As long as you can stay away from certain niggly parts of it, you can pretty much run this thing on any non-Windows platform. There's also zero impedance mismatch with shell scripting. It's a bit of a circular argument here, but let me show you what I'm talking about. We're installing software in this case. The point of ci.sh is to wrap a bunch of things, but the things that we're using in this particular application mostly install things. So I personally like zero impedance or as little impedance mismatches as possible. And what I mean is this. If we're installing, for example, Nginx, we go to the Nginx website. This is literally a screenshot I just took yesterday, and you'll see this. This is easy, right? We can install it easily because it's an Ubuntu team, blah, 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 and that's the code. Right? Now, that is shell script, right? This is what's a command. It's represented. You can run that in the shell. Every single website that you'll go to, every single one, 10 out of 10, will have this representation. 0 out of 10 will have this representation. Now, this is the same thing in Python, right? So we're going to do the same thing in Python. Nobody's going to do this. So I like Python as a sort of alternative scripting language. But you're not going to see this. So I wanted something here that looks like that, simple, straightforward, so that we don't have to do a bunch of translation and a bunch of sort of ceremony around basically just doing this. So that's the defense of Bash. All right, so let's go back to this script here. So before I do that, I want to give you a background on where I'm coming from and why I'm even telling this story, what I'm getting into here. This is a colleague of mine, and he tweeted this. He says, I can recognize a Garrett, this is me, Garrett code base anywhere in any language. And I didn't understand what he was talking about there. And then I thought about it. I'm like, actually I do have a little bit of a different style, and it does tend to show up quite a bit. So I took a look at this, and here's some code that I've written in Bash. Right? So we'll get into more Bash, but there's some Bash code. There's some Python code. It looks has a similar shape to it. And that's some Erlang code. And you can kind of look across these, and there's a similarity to that. We're going to see in direct contrast more traditional Bash, which looks nothing like this at all. So I'm wondering about myself if I have some sort of different problem that other people have, because most code, and I've looked at this, most code does not actually look like this. This is fairly rare, and that's why Michael says this is somehow a signature of mine. Really what we're talking about is sort of well-defined small functions. That's really the only style here. And I don't think that's something that I've invented. That's certainly not something that is unique to me, but it's seldom used. So I'm starting to wonder, do I have some sort of compulsive problem to do things my way? Like I've got a certain wiring and I've got to do it my way. And if it isn't my way, I have some sort of problem. That's the basis of this entire story. So we're going to get into that's the neurosis part. But there's some technical side too, so don't worry. Okay. My goal in software is this. This is it. This is what I live for. I want something to be completely, absolutely, perfectly, clearly obvious at a glance. That's a wonderful thing to experience in software. When you sit down and you can read something very quickly and understand the intention of the author. In this case, the author is ascribing a fairly obvious moniker to this object. I agree with that assertion. That's an apple. So my goals is I want at-a-glance obviousness. I don't like surprises. Once I understand something, once I think I understand something, I don't want to be surprised. Right, so I don't like surprises. And I have this sort of thing about correctness versus intent. Correctness, this is a niggle. This is not a really big point, but this is something I kind of talk about. We talk about correctness. Is correct code? Is it verifiable? Is it provable? In practice, I find that the problems that we define are really the problem. What problem are you carving out? You have a choice when you write software as to what you're going to do. Do you do A, B, C, or D, or some derivative? That's the problem that we face, is what problem do we solve? So the idea of correctness is this volatile thing. It changes. Right? What's correct one moment could be incorrect the next once you discover something. So it's very much a process of elaborating what it is we want to build. So that's a difficult term to apply as a standard, because it's changing. What is correct? It's also almost a moral term. What I like rather is intention, so that when something is written, you see what that author intended. So when I read code, what is the author doing? What is the author saying? Then I can reason about what it is that may be correct or working, or what it is I want to do with that code in some other context. So I like clear intention in code. Okay, let's go back to this. This is what my story is. We have this integration, this continuous integration script that runs all the time. And if you commit something to code in source and it breaks something, you're going to get emails and you're going to make people upset. And I've had a personal problem with this because I tend to just be really haphazard and like I just figure in time people will fix it, I'll fix it, I don't worry about it. So I'm breaking builds constantly and people are like, Garrett, would you just stop this please? And so I now have to get into this. I have to understand what's going on. So I'm taking a little bit of ownership and getting plugged into this thing. So I needed to make a very simple change to this script, what I thought was simple. So one of those things, you think it's simple and then you get into it and you realize it ain't that simple. All right, so let me make some remarks here. What I'm going to do is I'm going to get into some code that is actually not my code. My refactoring talks in the past, if you were here last year, I did a refactoring talk in Erlang and it was on my code. So I can beat the hell out of myself. I don't care, right? I don't mind it. It's fun. But this is someone else's code, so this is kind of sensitive, right? I don't want to be an asshole. You say, this guy has this terrible code, right? But this is an honest problem. We're right in the middle of sort of a problem that we all face, right? When we are working with other people, we'll run into code that we're tempted to call terrible or bad or ugly or whatever judgmental negative term. And so I initially came in and I'm just like, oh my God. But then I'm like, look, this is not right. This is actually not a very scientific point of view here. This is a moral, judgmental, tribal, primitive, it's not my form, it's not my camp. And I took a step back and said, this is not, as a professional programmer, this is not my right. This doesn't even make sense. This sort of moral judgment doesn't even apply. What I want is to understand what this script is doing, what it is sort of meant to do, and then I want to be able to change it in a way that is sustainable, is intelligible, is not going to cause entropy down the road. So this is now scientific. I've got to understand what this thing that works does. So now I'm shifting from this is bad code to this is actually good code. This is code that is running all the time. It's established a correct process. And it has accomplished something that it was set out to do. Whether I like it or not, whether it's easy to understand or not, is really not an issue. And so then I proceeded along this term to understand and then to clarify. There's no judgment here. This is an iterative process of improvement, taking something that works that may not be that understandable and chipping away at it to make it more understandable. So that's my approach at this point. I did get permission from my colleague to talk about this. I said I'm going to be nice, and I'm going to be so nice. But it is a little touchy because it's not my code. So I want to be sensitive to that. Okay. What I'm going to do here is I'm going to walk through. Let me show you. I've got to stretch down here. The code at a glance. Okay. So I'm going to scroll down this thing. You can see that? Okay. I'm going to scroll down this, and you're going to see how big this is. All right. That's it. I'm at the bottom. I'm going to go back to the top. That's the file I'm talking about. So it's not that big. I'm going to go through each of the sections, but I'm going to focus on one in particular, and we're going to go through an exercise. And this is an exercise that I tend to apply all the time in any language, and it's why Michael Neal says, this guy has this weird signature. So this is no intention to do that at all, but this is the process that gets me to that signature. So we're going to go through that now. Okay. So my story is this. I open the file, and then I read it as we would all read it, from top to bottom, because it's a script. It executes sequentially. So these are variable definitions, and I see this export, and I get a little concerned right away, because I know that this is being made available to other programs that are going to be running. And I'm starting to think about state. I'm starting to think about where it's defined, when it's defined, who consumes it, and what that interface is. That's all kind of functional DAO. I mean, it's good programming. But in my experience with functional programming, it's very much about controlling state. And in a function, in a pure function, it's very simple. These are arguments that go in. You get a result out. It's a transformation. In this case, we're side effect city here. And side effects make me nervous. So on a good day, this is really kind of makes me nervous. So I'm reading that going, okay, it's a bash script, relax, it's fine, it's not going to hurt you. It will hurt you, but I'm just trying to talk myself through this. This is the next block. All right, so this is very, very common in code, any language, even functional languages. I've seen this in ML, I've seen it in OCaml, I've seen it in Erlang. You'll see a big block of code, and you'll see a comment at the top. Now, I have a Pavlovian response at that point. When I see a comment at the top, what does this comment say? It says, update the development Tiger CLI Docker image. I'm thinking, well, if somebody took the time to write a comment there, what if we could just turn that into a function? So as it turns out, Bash has functions, thankfully. So what I'm going to do here is I'm going to just do a very simple refactor. I'm going to turn this block, because this actually is a function. It's just kind of executing in line. This is a function, so let's just do that. So I'm going to call this thing update the development Tiger CLI Docker image, because I don't know what it does. I'm going to take it for granted that that's correct. I'm not going to judge. That's fine. It's a good title. All right, so update, that's my function definition here. And this is the syntax for a function in Bash, and it looks a lot like JavaScript. A lot like JavaScript. Which reminds me of how similar JavaScript is to Bash. All right, as a language, to maybe not use on the server. Okay, I had a joke, but I pulled it out because I didn't have time. Okay, so I'm going to now just put that code into this thing. Now, that block of code, which is a function, I mean, it has a sort of a logical continuity to it. It hopefully does. It probably does. I mean, this is a script that's working, so I'm gonna give this thing the benefit of the doubt. So now I'm gonna just put that in there. Now I look at it and it's like, okay, now that's cool. I got rid of that comment, and now I've got this thing sort of identified as a function that I can call. And then I start to read it. I'm like, okay, if this thing, now this is an odd little syntax in Bash to say, is this variable set? So when you work with enough Bash, you'll recognize this. There's other ways of doing this, but this is actually a really good way of checking. Then there's a bunch of stuff here, but my eye goes right down to this. I'm like, oh, that's a comment. I know what to do with comments, right? Use an existing release. Well, that's probably what this does, right? So I'm just going to put a function there. Use an existing release. There we go. All right. Now I'm starting to calm, my blood pressure is starting to come down, starting to chip away at some of the sort of ambiguity of this thing. All right, but now I've got this clump here. But there's no comment. So, without really reading it, I'm going to come up with a function name for this. What's the right function name for this? Well, this is what I came up with. I sure wish that there was a comment here. Heck, just do stuff. That's the name of this function, right? There's no comment, so I don't know what it's going to do. It does stuff. So I'm expressing a little bit of regret, and ultimately, it's just doing stuff. I'm done. Look at that. That's a really nice, oh, wait a second. This is weird. If you don't know Bash at a glance, it's not obvious at a glance. So we want to make it obvious at a glance. So let's change this bit here. What can we do? Does anyone know? What can we do in Bash that could possibly clarify this bizarre syntax? Any ideas? I can use a function. Excellent. Well, let's do that. If skip release environment is not set. Now, I'm using kind of obnoxiously long names here, kind of to make a point, because I really don't know and I don't really care to refine the perfect short, terse name. I'm just kind of stumbling through this stuff. But that looks pretty good to me, right? I'm ready to commit. I'm ready to get this thing in a short revision. Now, I don't know about you guys, but this is probably not going to, that would be funny. Right, but that's not going to live very long in your repo. So I want to go and examine what this is. So let's go back to the original block and try to figure out what this stuff does. So pushd is a convention in Bash to basically change directories with the intention of getting back out to the original directory. So it's very common to have to run a command in a particular context. It's a little like object-oriented programming, where you have to set instance variables. You have to get your state just right, and then you invoke something. That's kind of what happened here. Oops, sorry. This is a battery problem? No. Nope. Oh, I'm going the wrong direction. All right, sorry about that. Here we go. Let's get back to the, there. Yes, okay. Yeah, so pushd is a convention. We're going to run this, so this is object-oriented, so I'm going to set my state here effectively. I'm setting current working directory. I'm going to run make clean. I know what that is. That's going to run a make file. I know clean is a target that's commonly defined in a make file, which means basically just delete all the artifacts. Okay, I know what that's doing. I'm not sure why we're doing it, but I know what's going on there. I'm going to set that aside for a moment because it doesn't really help me understand what's going on. This is interesting, so I come back with the pop, and now I'm going into the release directory. I'm going to run release, and then I've got some arguments here. So it looks like I'm running a release. That's what I believe is going on here. So why don't we name the function this? Create tiger release, I think. I think that's what's going on here. And I think we should use this convention more often. We should use the suffix I think, or dash I think, or underscore I think, or underscore hopefully in a lot of our functions. That would be honest. I think we would be like looking ourselves in the mirror and saying that's the right name for this, because that is the right name for this particular thing. Except in the back of my mind, I'm really bothered by this. This is weird, right? I can understand this is making a release, but why am I cleaning a different, seemingly completely unrelated project? And now I'm starting to get worried. Like, what is going on here? So now I really think the name of this thing is this. Create tiger release, I'm pretty sure, with some odd CLI clean first. That's the actual name of this. That's what this thing needs to be called. Right? So this is it. I'm done. Right? I really am. This is actually the right, this is the code that's been written. And I really am done, as far as my knowledge and my understanding. The problem here, and this is what sent me on a fairly radical journey, is I became very skeptical that there's a good understanding, or there's probably an understanding of the mechanics here, but there's something wrong. I believe that there's probably something wrong. This bit here seems strange to me. It may have been an artifact from some other, who knows where this came from, but it's not logical. It doesn't strike me as being clear and cogent. And when I run into something like that, I'm very reticent to just hammer at it and add things to it. It's a little bit like pouring gasoline, potentially pouring gasoline on a fire. So my tendency at that point is to step back and say, you know what, this is bothering me. I don't know enough about this. I'm concerned that I might be making things worse, so I'm going to take a different tack here. But for academic reasons, let's go through the rest of this thing and imagine what we might do with this code. Upgrade existing cluster. What do we do with that comment? What's our Pavlovian mechanical refactoring instinct? The function, absolutely right. There's not a lot else we can do here. What else? We can make it a better comment and more descriptive, but functions are good here. So that's a very clear, I don't know, I don't know what's going on there with the move thing. Pass on Terraform, that's a really long, that goes actually past the 79 characters here. But that would be a funny name for a function. That'd be a function, this would be a function. We've got creating configuration. And I'm reading the code, I'm kind of tracking with it. So I'm like, okay, I'm optimistic that this might make sense. But as I got into this, I realized there's some complexity to the script that I was uncomfortable with. I felt like this script might be doing too many things. And as it turns out, we're going to keep going here for an image, and so we've got more code. That could be a function. Okay, that could be a function. You get the idea here, right? And we're getting toward the end. I'm seeing some things. Wow, that could really go into a nice, clean function there. I don't have to look at that. That's a big mess of curl. Wow, look at the curls being used a lot. So I'm starting to kind of weaken and then give up. And I did. At that point, I'm done, and I'm just like, I don't feel like working with this file right now. It does a lot. It was overloaded. I know it worked. So what do I do at this point? I knew what I needed to do. So my tack at that point is to go in and create something that is separate. Right? You can go in and hack a file and make it do what you want. Or if it's a little bit it's overloaded or confusing or complex or you're not sure what to do, a lot of times it's good to just take a new parallel initiative and create something on the side and let them live together. The thing on the side may not be a drop-in replacement, but that's good because you want to focus on the thing that you want to build. So here are my concerns going into my work. Of course, I want clear, obvious intent. I want to understand state lifecycle. This is kind of getting into, this is really not functional. This is universal. You want to understand how state is created. where it's modified, where it's read. Modification is generally something you'd like to avoid. And it turns out in Bash, you don't have to modify things. You can actually do, I'm going to show you a pattern that I like to use that makes Bash a bit more read-only. Because modification of state is a tricky business. And it's tricky in Bash, it's tricky in any language. So that's definitely a pattern we can apply to our Bash. Interfaces are a concern. Specifically in Bash, we're talking about variables. We're in particular talking about exported variables, because those have all sorts of side effects. And then the arguments that we're using in our commands/functions. And really, this was it for me. Right? Does anyone know what this reference is? The rubber duck doesn't understand? Okay. So what does that mean? Rubber ducking, right? So when you have a problem, you're trying to solve something, and you're working through it, a really effective tool is you take a rubber duck and you put him on the table, and you're facing the rubber duck, and he stares and he listens carefully, and you explain your problem to the rubber duck. And you will know at the end of your statement and explanation if the rubber duck understands. You'll know, right? He'll tell you. He's like, you just look in his eyes and he'll say, I understood that or I didn't. That exercise is incredibly valuable in forcing you to articulate what it is you're doing. This thing failed the rubber duck test. I did this with my son a few weeks ago. He was doing one of these sort of story math problems. And those are difficult, especially for a young learner to sort of get his head around this thing. And I wanted him to start to describe the problem in a way that he understood so that I could understand he understood it. So I said, Elliot, the rubber duck doesn't understand, and he didn't understand. So I tried to find a rubber duck, and the best I could come up with at the moment was this thing. This is Rainbow Wolf. So we had a Rainbow Wolf on the couch, and I'd put it down on the table, and he's very interested in this point. It's like, this is the most interesting math lesson I think I've ever seen. And I said, Elliot, explain the problem to the Rainbow Wolf. And he was a kid. He's eager to try this. So he did, and he paused, and he struggled with it. He says, Dad, this is really hard to do. I mean, it's hard for me to articulate this and explain it. I said, this is exactly the point. This is like a little aside for rubber ducking. And if you don't have a rubber duck, I encourage you to go find the Rainbow Wolf, because it's more colorful, and it's got nice eyelashes that bat back at you. And so this failed the rubber duck. So I wanted to go and create something else. Now we're going to go into sort of my OCD Pavlovian model of programming in Bash. All right, so here we go. So let me show you that file quickly here. All right, so this is this guy. All right. So this is the top of the file. I'm going to scroll down. All right, that's it. Up and down. So it's pretty small, and we're going to go through it. And I'm going to explain what this is. So let me give you an overview of this. All of my Bash programs have evolved into this pattern. They all now follow this. And I found that this is working. I haven't changed this in a while. So I'm personally happy with this. I'd be interested to hear what my colleagues say. They usually disagree with me, so don't by any means think that this is right, but I can defend this. I think this is right. All right, so we have what I'm going to call header ceremony. We'll take a look at that. Variable definitions, some includes as libraries, quote unquote. Take a look at that. Function definitions, lots of these. And a single, usually, very simple script implementation. And that's basically what a script would look like in Bash, conceptually. So here is that script. I've commented out the sections here because really the main point is the implementation. When you run this script, this function, which is defined above, this is implemented. It's one function. Can you guess what that function does? Can anyone guess what that does? It initializes the new cluster. That's what that does. So that's Apple, right? That's got an Apple signature right on it. It's really clear what this does. And it also lines up, thankfully, with this thing, CI init cluster. Oh, I'm sorry, it's like Apple. I get it. I get what this does. There is no reason that every program can't be like this. This is simply a matter of talking to the Rainbow Wolf, understanding what it is you're doing, and then articulating that in a very clear and obvious way. There's no reason that every program can't do this. This is actually really, really simple. Okay, what does this look like? Here's the ceremony of the header definitions, variables definitions, and then the library include. This is also very simple. I'm going to get into some specifics here if I've got time. I might not have time. I probably do. I'll explain what this is. I'll explain what this is. That's ceremony that really every bash file should have. It'd be nice if you could have like a little macro or include there, but this is bash. You don't ship libraries with it. You just are opportunistic and use what you get. So you have to have a little bit of this stuff. This falls out of the scope of this talk, so I'm not going to talk about that. That's a trace flag that's pretty simple. This thing here is a variable. It's certainly not exported, but what I'm doing is I'm getting the source directory of the bash file itself. And this is weird sort of boilerplate for doing that. It's one of the ways, it's a better way of doing it. And now here I'm sourcing a library file. The library file, very quickly, just contains functions. So, support, that's all this does. This is just defining a handful of functions that are included effectively. The sourcing will load that and evaluate it. So what I'm doing is simply defining in line a bunch of functions. Now I've got a bunch of stuff available for me. This is like the basics of any language, but unfortunately it's seldom used. It's really fairly rare apart from like complex OS init libraries. People tend not to use this, but it's very good. It's very effective. It keeps your main scripts fairly readable, and of course allows you to reuse code. Okay, so that's these three things. I'm going to get now into the function definitions. I'm now getting into the function definitions. So init new cluster consists of this. I'm going to read it here. There's no comments. There's no confusion. It's simple, direct, sequential code. Destroy the existing cluster. Okay, makes sense. Clean the project. Okay, got it. Init the project, so initialize the project. Got it. Initialize the configuration. Okay, there's a lot of steps here, but they're clear and they make sense to me. Then I'm going to initialize the cluster. Okay, so this is sort of the prereqs, and then I'm going to do that, and then I'm going to test the cluster. That's correct. Ooh, correct or not. This is what I want. This is my intention. This is exactly what I want to do. So there it is, right there. Every single Bash, Python, Ruby, Erlang, ML program can look like this. Some languages encourage this, but you can do it in Bash. Bash, it's crazy. Okay. Here's some more. We don't need to get into the implementation details, but this is destroying the cluster. So now we see some of the implementation details here, but it's really fairly simple. I have an echo, which is not a comment. It goes out to the user to sort of see progress here. It's like a log. And then I get the implementation, refresh, destroy. It can destroy, again, taking sort of complex conditional logic, putting into function, right? Basic stuff. Here's the rest of it, initialize the project, and you can read very simply what each one does. The intention is clear. What am I doing? I'm going into a directory, I'm running a command, coming out. That's it. There's no scrolling of things that I've got to go parse and infer and sort of decompile and understand. It's all the work is done here for me. And this works. This is all done. All right, that's it. That's it. So what I have now is a refactoring, not of the whole thing, but of the snippet that I'm interested in it. Now, is this a matter of going from bad to good? Like I'm going from some evil thing to some virtuous thing? There's a temptation to think of it that way, but that's actually completely wrong. The first thing is good because it works. The second thing is good because it works as a byproduct of the first work. I couldn't have gotten that stuff done because I just copied that stuff in place. So the work that was done initially, which is very ad hoc, I'm just getting this thing to work. Right? That's good. That's good code. It proves out the problem. It runs the problem. It verifies it. And I could be very happy with that code if I never had to modify it, if I never had to read or understand it. And in fact, I was very happy with it. I didn't know it existed. I was perfectly happy until then I had to modify it. And that triggers another change, another iteration in the process of writing software. Now we need enhanced clarity because we need to verify the logic that we're involved in here. It sounds basic, but we often don't do it. We can be 20, 30-year veterans of software. I see this all the time. We don't do this, but we ought to, I think, in terms of a progression. Okay, so really quickly for Bash, because I want to get some time for questions. I have some specifics here in case you were wondering about Bash, but this is not a tutorial or an exhaustive listing of all the things that you need to learn in Bash, just like as it wouldn't be in any language. But there's sort of interesting things that I think are not always obvious, but are valuable. So we know this is true. Globals are bad, okay. So we know, and we think Bash is like global city. Well, there's ways to deal with globals in Bash that I've adopted that I like a lot. So first of all, you've got globals everywhere. So there's no way that you can get away from them. So don't for a moment think you're going to start to like get away from global state and side effects in Bash. Right? Again, it's not a functional language. That was a joke. There's a DAO that we can apply to this, but there ain't no function. There's no monads here. I'm sorry. Okay, here's what I like for globals. First of all, I like to avoid using environment variables as an interface to a Bash file. I'd much rather pass an argument. Now, where does that instinct come from? Well, that comes from my use of functions, where I prefer to see arguments passed in as opposed to the poking of global state. By the way, instance variables in an object, global state, global variables. They're global to that object, right? And all the badness associated with global variables is now associated with the instance variable. So that's just an aside. It's a rant on the idea that if we just reduce the scope somehow, they're no longer as global. There's a reduced scope, but they're still global. So I like to avoid this kind of pattern of configuring via poking a bunch of state up in environment variables. I like to minimize the script variables, so minimize the interface. So keep a clean interface as minimal as possible. And then what I do is define scripts that are effectively used as variables. And I'll show you an example here. So define script variables using args. So here we go. Sorry, this is what I mean. Use functions to compute derived variables. Here's an example. This is setting a variable using the argument here. And this is a very odd notation to say it's required, so fail if it isn't started, and use this as sort of a message to the user. It's terrible. It's Bash. Welcome to Bash. So if you just get used to seeing that and just relax, it's fine, right? It is fine. So if I don't provide a single argument to this, it's going to crash, and we're going to see a really weird looking, but I'm going to see this very primitive. So it's like a very primitive get opt help system. Very primitive, but it works. So now I have a project, which is my first argument. Now, if I need a derivative of that, I create a function that is effectively just generating, right? So this is now a subdirectory. The temptation would be, and this is what I've done in the past, would be to say scripts_dir and define it now as a function, actually define it now with project up here as a literal, as a variable. Rather, I like this. This is virtuous for a number of reasons. The main reason is it simplifies and it reduces the number of global variables here, which ultimately reduces the complexity of your context. Context will kill you with surprises. This is, if you could eliminate context altogether, you've got a nice interface to some operation. So that's what we're trying to do. We're trying to chip away at context. And here's how it's used. Scripts directory is, and this is the syntax for calling a function, returning a standard output into this string. This is echoing. So he's going to call this and evaluate it. So this is now returning this. So this is a way to inject that. And you can use that as a variable reference. Here are a handful of other patterns. This is kind of a cool pattern. This feels very functional, I guess. I'm really not trying to make it a function. You understand, right? That's clear. I'm not on record saying it's a functional language. Okay, got that. So this is the usage. So skip that for a moment and just take a look at the usage here. So I'm going to call SUMList. I'm going to pipe that. I actually wish this feature was in more languages. It's very nice. I'm going to pipe this in to use read, which is going to pull off it's going to read a line and assign that to variable x, and then I can do something with x. And in this case, my generator of values is just echoing lines. Now that gets enumerated here, so that's going to be each one of these is going to read off of that until it gets to the end of the file, and that's going to stop. Then I'm just doing something with that. That's a nice pattern, and you can use that very easily and elegantly. So take a bunch of complex things, for loops and other things, put them into generators and use this pipelining. I like that. Boolean checks, we've seen this. We can take really insane and complex logic that we'd be tempted to just embed it and give it a name. Right? Now we have a function. We can understand what this is going to do. We can reuse it. All the good things here. And these are a couple of valid examples. This one, I like test. Test is a program that will allow you to evaluate different expressions. You can do Booleans and file checks, etc. This will return a 0 exit code if it's successful, or 1 if not. and 0 in bash generally indicates success, so that's true. And in this case, we're going to call the true command, which always exits with 0, false always exits with 1. You get the idea. So this is a nice pattern as well. You can eliminate and clarify logic quite a bit. Getting to the end here, these should, in my opinion, be used in every single thing you do. This says crash on an error. If you don't set that explicitly, your bash program will continue to run happily in the face of any error. Happily, just plowing through. And I don't understand why that's the default behavior. It is. I guess it's the universal do something. It's the doggedly determined to just do what you tell it to do. So setting that will cause that behavior to change. This will fail if you use a variable that's undefined. That's a bug. Like if you don't have a defined variable, in my opinion, you shouldn't continue. The odds are you mistype something. The odds are not that you expect. In some cases, you may expect something. I'm going to show you an example of how to handle that. And then this is finally the last one in sort of the trinity of fixing Bash's terrible default settings. If you pipe something and that something fails, it will succeed. So you can eat errors through pipes, unless you set that. Okay, finally a couple things with arguments. I use local arguments, but you've got to know a few things. I use this syntax here to indicate it's required because it'll fail if it's not set, even if set E is not set, dash E, dash U. You can provide default values this way. So if you are using set U, meaning crash if it's undefined, you can define a default value, and these are both explicit. I know what's going on here, so this is sort of idiomatic, but it's expressing an intention. This says it's required, this says it's not required, and I get a default value. If you wanted the default value to be empty, just default is delete. It's just dash curly bracket. This is a terrible feature. It is the most shocking and horrifying thing ever, the source of all sorts of bugs. If you use this notation, backticking would also do the same thing. Any exits that you call here are eaten. Any type of failure that you want to generate and crash your program will fail, happily fail, and you'll continue, and you'll have a bug in your program. The reason is you're both simultaneously defining the local and assigning it. It's very strange. There's an ordering issue. You get into it, you'll understand why it happens, but it's a terrible problem. Here's how you fix that. You declare it locally above, and then you assign it on a separate line. It's probably the biggest pitfall that I face in this language. But that's it. I mean, other than array passing, which I don't really want to get into. It's terrible. All right. Finally, use local. I was afraid of local. I said, don't use local. Local is terrible because of this. And then I started using this underscore convention, which kind of comes from Python. Well, it probably comes from all sorts of languages, but it's very common in Python to denote a private or don't use me argument. The problem, of course, with this is that if somebody else decides to use the same name and you call him, you've redefined your value. That's bad. That's a surprise. That's a terrible thing. So use local, but just watch out for this thing. Right, so that's my dogma there. Okay, well, I'm going to wrap up very, very quickly and hopefully have time for a question. So Bash is not a functional language. That was clear. Programming is not either or. This is not a moral debate. We're not talking about evil and good here. We're talking about a process of programming. Writing terrible code is actually probably a misnomer. That so-called terrible code is code that's experimental and trying to prove something. That's fine. Prove it. Understand it. Get it to work. Learn from it. And then make it clearer. Make it better. As needed. Right? I was perfectly happy not knowing about this, but now I've got to own this. I've got to get into it. And I would like to understand what it is I'm doing, so that's my refactoring. Somebody else might not have that point, and it might be fine. I don't think that there's a moral topic here. Okay, everyone has his or her moral issues. They're wrong, of course, and I'm right. Ha ha. Just kidding. 1 or 2 questions before we close. Comments. Disappointments that Bash is, in fact, not a functional language. Yeah.
I thought it was great talk, but just kind of one concern I have is that, like, I understand your justification at the start as to like Bash being universal, but I'm just wondering if we're approaching this in a slightly wrong way.
Mm-hmm.
A lot of the kind of problems that are overcome here, like, are already solved in other ways. Whether it's like type checking or syntax checking, which effectively comes for free with a compiler. That's not something that we need to even think about.
Yeah.
So
well, so yeah. So what language should we use?
I don't know. maybe we use a functional language that pumps out Bash.
Yeah.
And then we can do that in a type.
Yeah, that's a good idea. I mean, that's certainly what the Elm ClojureScript space is doing. Absolutely right. That is another example of why Bash and JavaScript are basically effectively the same type of thing. They really are.
It's like assembly.
Same types of problems, same types of horrible problems. No, I think that's right, and that's a really good point. I do believe, though, that there's something to be said for sort of idiomatic use of a language, and I think that this. So that's true now. Newcomers to the project are going to have to get into that, and that may be completely justifiable. If this was a critical system, we wouldn't be using Bash for this. So in that particular case, I don't know, but that's a really good point. The ability to not worry about having to finely tune all these things with patterns and conventions, but using a proper modern statically typed language to generate this code. Could be, yeah. Question, comment? I'm over time, I think. I think I am, but should be. Any other? I like questions anyway. Sorry, I didn't leave enough time, John.
So you were very careful to say that the code as originally written looked like that because it was just to get it working, the result was
I was very careful. Thank you for pointing. Yeah.
Does that mean that you would recommend when you're just trying to get something working, writing code in that form?
That's a great question. So the observation is I was very careful because I really do. I mean, I work with amazingly talented people, full stop. And I do think that there's some pretty horrible things going on there, but it is a function of evolution, and I think it's closer to the truth that this is good because it establishes a basis of working code. But the question is, observation is, why is it impossible to write the second style or a different quote unquote better style initially? It's absolutely possible. When I started to adopt this mode, I would often write something in a slightly more clumsy and awkward way and then refactor it immediately. And then in time, I got very good at just doing it directly. So I don't go through the intermediary steps now, and I think differently, and I think that's virtuous. I would advocate for that. So I would encourage people to adopt this. But I'm taking a bit of a pragmatic approach in a collaborative setting here. So I would encourage everybody to use this and get better at it. There's absolutely no reason that you have to go through that initial stage if you don't, in fact, have to. So. Okay, one more and then we're done. One more. It has to be one more, otherwise we're not going to be done. So somebody. Yeah.
So would you agree with the statement that a functional language is essentially just using lots of functions?
I really hesitate to talk about it in the room with two creators of Haskell. I really hesitate to even say a single word other than what I just said. No, I certainly wouldn't. I think that using lots and lots of functions can get you, what was it, a pan-universal truth? I think that seems right to me, but I'm really not the expert. I found it practical. I do this daily for a living. I don't know if it maps to truth, and I don't know if it goes beyond the four walls of my office out into different versions of our universe. I'm going to take Dr. Wadler's word on that because I don't know. You're probably right. I'm not going to answer it. I don't know. I'm terrified by the people here in the room. So with that, I'm going to close. Thank you very much.